Alrighty, Year 9. So before we start the lesson, what I'm going to need you guys to do is download that worksheet. You can just pause this video for a moment, get that worksheet and work along with the video. Alternatively, you can have a crack at the worksheet on your own, but the video is pretty much going to go through most of those answers for you. So it's a great benefit if you watch the video. So let's get started. So a little bit of revision again. So reminding ourselves that most earthquake and volcanic activity happens around the Pacific Plate, so that ring of fire. Now we touched on this in the last few lessons. The Pacific Plate is one of the biggest plate tectonics on the Earth, and it hosts most of that activity around its edge. And further revising, so there's the four main layers of the Earth. So we've got the outer layer, which is the crust. It's between 5 and 50 kilometers thick, and it's in a solid state. We've got the mantle, which is the thickest layer, and it's about 2,900 kilometers thick, and it's made of a semi-solid molten rock. So it's important to note that it's semi-solid. We've then got the outer core, so that's about 2,300 kilometers thick, and it's made of molten liquid iron and nickel. That's also important to remember. So the mantle is a semi-solid, and the outer core is a liquid mixture of iron and nickel. And then our inner core is the innermost layer, and it's going to be a solid. So it's about 6,000 degrees Celsius. So it's important there to note down what the states are of each of those layers, and we'll start to discuss that later in this lesson and in the next couple of lessons. So during this lesson, you guys are going to learn about the features and causes of earthquakes and how they relate to plate tectonics. And to be successful in this lesson, you need to be able to identify the features and explain what causes earthquakes and link that to plate tectonic theories. So we touched on plate tectonic theories in the previous lesson. Now we're starting to link those theories into our understanding of volcanoes, plate boundaries, and earthquakes. So what are earthquakes? Now we've slightly touched on earthquakes in a couple of the other lessons, but as a bit of a plot summary, earthquakes are a sudden release of violent ground energy into the crustal layer of the Earth. So over time, this pressure and this energy builds up as a result of friction, which is being caused from these plate tectonics rubbing against each other or catching on each other. Now, we've learned about this in a couple of the previous lessons where the plate tectonics are either going to be convergent, divergent, or transform plate boundaries. When you've got a convergent or a transform plate boundary, those plates are going to run into each other and essentially create a lot of friction against each other, and every now and then that energy builds up so much that it just releases itself in the form of an earthquake. Now, this tends to happen along faults, so essentially that pressure builds up and those land masses or those rocks fracture or split themselves. So this is what we call a fault. So a fault is a fracture or a zone of fractures between two blocks of rock. So in this case here, we're talking about the plate tectonics themselves. And there's three different kinds of faults that we can note down that scientists have discovered. So the first one is called a strike-slip fault. Now we see this a lot more with the transform plate boundaries, and you can see this in the image on the left by the direction that the plate boundaries are going. So they're going side to side against each other, so they're sliding against each other in the opposite direction. That's going to be a strike-slip fault, and you see those mostly with the transform plate boundaries. We've then got what's called a normal fracture or a normal fault. Now this is when the two rock formations, or two blocks of rock in this case, split in opposite directions to each other. So one goes up and one goes down, and it creates a bit of a ledge, like a really sharp incline that you would have to climb up, which you can see in the middle image. Now, there's an opposite version of that, which is called a thrust or a reverse fault. Now, this is when the fault itself actually goes in the opposite direction to a normal fault. So the best way to explain that is by having a look at the photos on the screen. So the one on the left is talking about a strike-slip fault. The middle one's talking about a normal fault, and the one on the right is talking about a thrust or a reverse fault. Now, faults aren't the only things that cause earthquakes. There's a variety of reasons that an earthquake might happen. The main reason being the plate tectonics are inducing them. So those plate tectonics are floating on the upper mantle. So you've got the asthenosphere, and you've got the convection currents that are moving those plates over time. Those plates are then rubbing against each other or smashing into each other, and they're causing those earthquakes. Now, earthquakes can also be caused by volcanic eruptions. So by having a large amount of energy being released in the form of a volcano, sometimes the rocks in those plates might shift or might release also additional energy, and so volcanoes themselves, the eruption can cause an earthquake in a local vicinity. Earthquakes can also be caused by ground collapses, also cave-ins. So when you've got a large amount of rock being displaced suddenly, all of that energy can be thrust into the rock and be created into a form of an earthquake. Now, this doesn't tend to be a very big earthquake when we look at the Richter scale in a couple of lessons, but this here is still an example of what might cause an earthquake. And finally, we might have induced earthquakes. So this is all to do with human activity. Now, if we release large amounts of energy or put large amounts of energy into like rocks into the ground, we can cause unintentionally a man-made earthquake. So this could be formed from things like mining or drilling, even the release of large amounts of energy from things like weaponry, so like nuclear bombs and stuff like that. So we now sort of understand what causes an earthquake. Now we need to understand what an earthquake comprises of. So when we look at earthquakes, there's going to be three main features, and you can probably see them already on the right-hand side in the image, but we'll touch on them now. So we've got the focus of the earthquake, and this is actually where the origin of the earthquake is. So the earthquake itself is going to happen underground somewhere, and the focus is that location, that specific spot where that energy is being released from. So that's where all of that energy is going to be sent out from. The next main feature that we have is the epicenter. Now, this is the location directly above on the surface of the Earth, like on the surface layer of the crust, where it lines up with the focus. So if you just had a straight line going from the focus all the way up to the surface of the Earth, you would find the epicenter. So that's where most of that energy is going to be released at. And then you've also got the seismic waves. Now, the seismic waves are the actual energy that's being released. Now, we're going to touch on the waves in just a second, but we're going to do an experiment in a couple of lessons that's actually going to explore the features of those seismic waves for earthquakes. So, talking about the seismic waves, when an earthquake strikes, there are two main types of seismic waves that are released. Now, there are a few more, but for you guys, I only need to really focus on the first two. So the first one is called a P wave, so a primary wave, or a longitudinal wave. Now, these are waves that, if you think of it in terms of a slinky, it stretches out and then comes back in. And you'll notice that there'd be clumps of slinky that are a little bit thicker or more condensed than others. So some parts are stretched out, some parts are really close together. That's an example of a P wave. So P waves go up and down and essentially create that pressure. Now, the second type of waves that we've got are called S waves or secondary waves. Now, we're going to touch on these types of waves in depth a little bit more later on. But these waves are called transverse waves. So if you have a slinky and you stretch it out, but instead of pushing it backwards and forwards, you shake it side to side and you get lots of waves, kind of like what you would think of with sound waves or light waves, which you would have learnt about in probably year 7 or year 8. That's an example of a transverse wave. So essentially thinking of it like it's got ups and downs, and it's like a bit of an actual wave. Now, these waves have different properties that allow scientists to detect the origin of the earthquakes. Now, we're not going to touch on that today. We're going to touch on that in the next video in Earthquakes Part 2. But for now, it's important to remember the two different types of waves. So we've got P waves and we've got S waves. So P waves being longitudinal and S waves being transverse. So yeah, as we talked about just before, in the next video, we're going to look at how S and P waves travel in the Earth, and we're going to investigate the properties of S and P waves. So you guys are actually going to do an experiment at home, which hopefully will work out, but I reckon you guys will enjoy it. So once you've finished watching this video, if you haven't already, make sure you're going ahead and filling in that worksheet that we've attached to this lesson. Make sure that you submit that to your Google Classroom, so your individual Google Classroom, and also take some time to finish working on your assignment. Now, your assignments are going to be due on different days, so Miss Bathgate and Miss Ireland's classes, your assignments are due on Thursday. Everyone else, your assignments are due on Friday, but double check on the Google Classroom because that might have changed in the meantime. But we're going to release a video on Thursday that's going to help you guys summarize and go over and check your assignments to make sure that you've included everything so that you guys are doing really, really well with your model assessments. But other than that, enjoy your lesson today, good luck, and happy Tuesday.